So this video doesn't contain any new material. I'm just going over the problems that I assigned last week. I showed you the answers yesterday, so I just wanted to talk about them. And still, if you have any questions, even after watching this, just email me, let me know. Also, if any of you still need a calculator, just email me and I will get one to you. So looking at number 8, this was just from the definition. The p-value, the p stands for the probability value, and it's just the actual probability of getting the sample mean if the null hypothesis is true. So again, with the p-value method, you really don't have to keep drawing a sketch of the normal distribution. It's just there to be helpful, to emphasize, to give a nice visual of what it is we're comparing, and we're just comparing areas. So the only time we need to double a p-value is when it's a two-tailed test that we have to find. We need to total the area that's shaded, so that's why we just add the two shaded areas together, or we just double we're not doubling the p-value, we're doubling the area to get the p-value. So in number 9, the p-values were all calculated, so I hope it didn't confuse anyone when it was a two-tailed test like in B and D. The p-value was already there, so there was no need to double that value. So that's all we're comparing, so that's what I have written out here. So in A, we're just comparing. We're always looking to see if our p-value is greater than alpha, that means we do not reject the null hypothesis, and if our p-value is ever less than or equal to alpha, then we do reject. So in A, the p-value is greater than alpha, so we do not reject. In B, like I said, it was already found and doubled, so the p-value here is the 0.0684. That is less than or equal to the 10%, so we reject the null hypothesis. In C, again, a one-tailed test, it's not telling us which side. We have the p-value is a 0.0153, which is greater than 0.01. We do not reject the null hypothesis. In D, again, it was already doubled to give this to us, so the p-value is less than alpha. We reject the null hypothesis. And in E, again, our p-value is less than alpha, so we reject the null hypothesis. Now, in number 10, it did not state what alpha was, but the question was to find the p-value for the test, and just on the basis of the p-value is the researcher's claim valid. So even though I have all these steps written out here, it wasn't really asking to go through the whole test just to kind of find the p-value, but I still showed all the steps here, writing out that the null hypothesis is the mu equals the 52. That is our claim. Just read the wording. The very first sentence tells us that it could be something else. It doesn't mention greater than or less than. So here the alternative hypothesis is that mu is not equal to 52. In step 2, we calculate the test value very carefully. So make sure, because it could be misleading, if you're typing this in, you have to put the parentheses around that denominator. So you get the 8.69. That is a really large number. Think that that's telling us that's how many standard deviations away from the mean we are. So even though I had it drawn in, it's even further away. Looking over here, we have a very small area on either side. So if you use this, the positive z value here as your lower boundary, you're getting a very small number, practically 0. And if you double practically 0, it's still practically 0. So the area on the calculator, or p-value, is going to be 0. So it doesn't matter what alpha was chosen ahead of time. If it was 10%, 5%, or 1%, that's what 4 is saying. So alpha is not mentioned, but since the p-value is 0, it's less than any alpha that will be chosen, so we would reject the null hypothesis. And then, even though it wasn't really asking for all these steps to be written out, we're still writing that there's enough evidence to reject the claim, so the claim would not be considered valid here. All right, for number 11. All right, so here the claim was the alternative hypothesis. Because of the question, can be concluded that the average farm in Oregon differs from the national mean, so it's something different. We don't know if it's greater than or less than. Again, we find our test value. It is a two-tailed test, so I'm putting a negative 170 over to the left of the mean and a positive 170 to the right. So finding the area on each side, we need to double this, or add them together, or double it to get the whole p-value, which is almost 9%. So comparing this, our alpha is 5%, so our p-value is greater than alpha. Our decision is to not reject the null hypothesis. There is not enough evidence to support the claim. So if we do not reject the null hypothesis, it's like we have to go with it. So there is not enough evidence to support our claim that the average farm size differ from 444 acres. All right, number 12 was some raw data. So if you didn't have a calculator, hopefully you used or can use an Google Sheet, type this in, and then just type in the formula for finding the average here of all these values. Even though the raw data, I think I had this rounded out to one more decimal place further, but assume because of the what the standard deviation was, 13.42, so I just rounded it, and I know it kind of goes against our rounding rule that we're used to, but based on that, I rounded it out to the hundredths. So here our claim, we're seeing more claims be the null hypothesis. So it's mu is equal to 60. Alternative is it's something other than 60. Our test value here happens to be a negative 0.03. Again, this is a two-tailed test, so the area we're finding, because that 0.03 is very close to the mean, we're doubling this, we're getting a very large, so like 97.6% of our area is shaded, definitely greater than our alpha, so we do not reject the null hypothesis. We have enough evidence, there's not enough evidence to reject the claim that the average number of tickets issued is 60. So again, our claim was our null hypothesis. There's not enough evidence to reject the claim, is how we want to word that. All right, so for 13, again, looking at the null and alternative hypothesis. In this case, the claim is the alternative hypothesis. Going back to the wording here, test the claim that the average stopping distance of the company's buses is actually less than 264 feet. So we're looking at the claim over here. Our test value, very carefully calculated. Again, make sure that when you're typing that in, if it's different or separately, still be careful. You should be getting a negative 2.53, which makes sense. If we're less than, we're over here for a left tail test. Our p-value turns out to be 0.0057. That is less than our alpha at the 1%, so we reject the null hypothesis, so there's enough evidence to support our claim that the average stopping distance is less than 264 feet. Now, number 14, I won't say this, it was really a trick question, but it was still knowing the fact that you have to choose alpha before the test is conducted. We can't just change it. You could still look at it, but the contradiction at the end was that it really wouldn't matter because alpha needs to be stated and you have to stick with it before you run the test. So here we're going back to the critical values, not a p-value. So in part 1, the critical value turned out to be 2.33. Alpha is the 1%. Our test value turns out to be 1.97. So we have the critical region, which is right here. But if you notice, our critical or our test value is outside of that. It's in the non-critical region, so we do not reject the null hypothesis. When we change alpha, we now get a critical value at 1.64, 1.65. So everything in red here is the rejection region or the critical region. Now this 1.97 falls within it. Had the researcher chosen the 5%, they would have had this as their decision to reject the null hypothesis. But again, not really a trick question, but we need to just remember there's no contradiction here since alpha should always be chosen before the test is conducted. All right, guys, so continue working on this if you need to finish worksheet 8.2. I've already posted worksheet 8.1, 8.2. I'm giving you a few more days. So on Thursday, I will post the answers first. Just the answer so you could see, and then the next day I should have a video going over each one, or maybe I might wait and see what you guys have. If you request certain questions, then I'll put those together, but chances are I'll probably just put everything on there. So we're going to look maybe by the following Monday. I'll probably give a quiz over 8.1 and 8.2 before we do anything else moving on to 8.3. We're just taking our time, so please use this week to get caught up on worksheets 8.1 and 8.2, and then the combined worksheet that I just posted today as well, or yesterday rather. All right, take care, guys.